For the last few years, Nvidia's story has felt almost inevitable. GPUs power AI. AI demand explodes. Nvidia wins. Simple. Almost boring in how obvious it's been. But the most important Nvidia move of the past year didn't involve a flashy new GPU, a keynote, or a record-breaking benchmark. In fact, most people barely noticed it at all. Quietly, Nvidia committed roughly $20 billion to a company most consumers have never heard of. Not to buy it, not to shut it down, but to learn from it. That company was groq, and the move signaled something subtle but profound. Nvidia is preparing for a world where GPUs are no longer enough. Here's the uncomfortable truth for the AI industry. Training big models is no longer the hardest problem. It's expensive, yes. It's impressive for sure, but it's increasingly solved. The real bottleneck, the one users feel, the one companies pay for every single day, is inference. The moment an AI model actually responds to a human, the moment latency matters, the moment costs start compounding. Every time ChatGPT answers a question, every time an AI assistant summarizes a meeting, every time a recommendation engine updates a feed, that's inference. And it turns out inference behaves very differently from training. It's less forgiving, less predictable, and far harder to optimize at scale than most people expected. Nvidia knows this because its biggest customers are already feeling it. Cloud providers, startups, and product teams are discovering that inference costs don't scale linearly. They explode, and when response times slip, users notice instantly. So Nvidia made a move that doesn't look like domination at first glance. No acquisition headline, no regulatory battle, just a licensing deal and a quiet transfer of some of the best inference engineers in the world. That raises an important question. Why would the most powerful company in AI hardware decide not to buy a smaller rival and instead bet billions on inference-specific technology? The answer reveals Nvidia's real strategy. And once you see it, you realize this wasn't just about groq or chips or even AI performance. It was about owning the most valuable moment in AI's future. The instant a machine responds to a human. And that's where this story really begins. For most of the past decade, Nvidia's story has been simple. GPUs became the engine of modern AI, and Nvidia owned that engine. But the groq licensing deal marks something different. This isn't just a new product line or a marginal improvement. It's Nvidia placing a bet on where AI value is heading next. Internally, people close to hyperscalers have been quietly saying that training workloads are starting to plateau in urgency. They're still massive, still expensive, but they're increasingly predictable. Inference, on the other hand, is chaotic, real-time, and user-facing. That's where problems show up first. A former cloud architect recently described inference traffic as the messiest part of AI infrastructure because it spikes unpredictably and users notice every millisecond of latency. Nvidia has always thrived by positioning itself at the hardest bottleneck in computing. GPUs were that bottleneck for training. Inference is becoming the next one. This deal signals Nvidia acknowledging that the center of gravity is shifting, and acting before that shift becomes obvious to everyone else. That's what makes this one of the most important moves since CUDA itself. Training large models still captures headlines because it looks impressive. Massive clusters, billion-dollar data centers, weeks of compute. But economically, the excitement has started to move elsewhere. Several large AI startups have admitted privately that their biggest cost surprises didn't come from training models, they came from serving them. One CEO joked that training felt like buying the factory, while inference felt like paying rent forever. That distinction matters. Training is episodic, inference is continuous. Every chatbot response, every image generation, every recommendation runs inference. As more AI features move into everyday apps, inference traffic grows quietly but relentlessly. A productivity app adding an AI assistant might double its compute bill overnight, even if the model itself never changes. Cloud providers have started optimizing their pricing around this reality, offering cheaper training credits but charging premiums for low latency inference. That's a tell. When the pricing models change, it usually means the value has shifted. Nvidia sees this clearly. Owning inference isn't about winning one big training contract. It's about capturing the ongoing economic heartbeat of AI. Inference is the moment AI actually becomes useful. It's when a trained model meets a real user under real constraints, with no room for error or delay. Unlike training, inference happens millions or billions of times a day. Each instance might be cheap on its own, but at scale, it becomes one of the most reliable revenue streams in tech. A telling example came from a consumer AI company that rolled out a voice assistant update last year. The model itself hadn't changed much, but response times dropped by 200 milliseconds. User engagement jumped noticeably within days. Nothing about the intelligence improved, just the speed. That's inference at work. From a business standpoint, inference behaves like infrastructure tolls. Once an AI feature becomes core to a product, you can't turn it off. You can optimize it, but you still pay every time it runs. That's why investors have started paying closer attention to inference efficiency metrics rather than just parameter counts. Faster, cheaper inference doesn't just improve user experience, it determines whether an AI product can exist sustainably at all. GPUs are extraordinary machines, but they were never designed specifically for inference at global scale. They're flexible, powerful, and general purpose, which is exactly why they excel at training. But that flexibility comes with trade-offs. Inference workloads often need predictable latency, energy efficiency, and deterministic execution, not raw peak throughput. Engineers working on real-time AI systems often describe GPUs as overqualified but inefficient for inference. It's like using a race car to deliver groceries. It works, but it's not ideal. One cloud provider quietly admitted that inference clusters built on GPUs were underutilized most of the time, simply because the hardware wasn't optimized for bursty real-time traffic. As AI products move closer to users, phones, cars, call centers, these inefficiencies become costly. Power usage, cooling, and scheduling overhead all add up. Nvidia understands this limitation better than anyone because it hears the complaints directly from its biggest customers. The groq deal isn't an admission of GPU failure, it's an acknowledgement that inference has different physics, and winning there requires different silicon philosophies. Groq took a radically different approach to AI chips. Instead of optimizing for flexibility, it optimized for certainty. Its hardware architecture focuses on deterministic execution. Every operation happens exactly when expected, with no surprises. That's incredibly appealing for inference, where predictability matters more than raw versatility. There's a well-known anecdote from an early groq demo, where engineers ran a large language model and could predict response latency down to the microsecond. That kind of consistency is almost unheard of on general-purpose hardware. Developers loved it, but it also exposed a trade-off. Groq's approach sacrifices adaptability in exchange for speed and efficiency. This made groq a fascinating outlier. It wasn't trying to replace GPUs, it was solving a different problem entirely. For Nvidia, that made groq less of a competitor and more of a missing puzzle piece. Instead of reinventing that philosophy internally, Nvidia chose to license it, a faster path to mastering inference-specific design without disrupting its existing GPU ecosystem. On the surface, the decision not to acquire groq outright puzzled many observers. Nvidia has the balance sheet, it has the regulatory expertise, so why license instead of buy? The answer lies in speed and optionality. Acquisitions come with friction, integration risk, cultural clashes, regulatory scrutiny. Licensing gets you access immediately. By structuring the deal this way, Nvidia gained rights to groq's inference technology and, just as importantly, brought key engineering talent inside without dismantling the company entirely. That's a subtle but powerful move. It allows Nvidia to experiment, integrate, and iterate without betting everything on a single architectural path. There's also a signaling effect. Licensing says we don't need to own you to learn from you. That keeps doors open with other specialized chip startups who may now see Nvidia as a partner rather than a predator. In a market where innovation is fragmented, that reputation matters. At this point, it's tempting to think Nvidia just wanted faster inference chips, but that framing misses the bigger picture. Nvidia didn't spend $20 billion because groq was special. It spent it because inference itself is becoming unavoidable. Every AI interaction you care about, search, chat, recommendations, runs inference. And every one of those interactions creates a dependency. Once users expect instant AI responses, latency stops being a technical detail and becomes a product flaw. Nvidia understands that whoever controls inference controls how AI feels to the end user. This wasn't about buying a chip design, it was about removing uncertainty. By locking in access to inference-optimized technology, Nvidia ensured it wouldn't be boxed out of the most visible layer of AI. Training happens in data centers, inference happens in people's lives. That's the difference. So if this wasn't really about groq, The real question becomes, what does Nvidia want to own next? Nvidia's long-term strategy has always been about control points. CUDA wasn't just a software tool, it was a way to make GPUs indispensable. The inference push follows the same logic. Nvidia doesn't just want to sell chips, it wants to define how AI moves from model to product. By expanding into inference-specific hardware and software, Nvidia positions itself as the default choice at every stage of the AI lifecycle. Train on Nvidia, optimize on Nvidia, deploy on Nvidia. That continuity reduces friction for customers and increases switching costs. A startup CTO recently summed it up bluntly. Once you're fully inside Nvidia's stack, leaving feels like rewriting your company. That's not accidental, it's strategy. Inference completes the loop. Without it, Nvidia risks being relegated to the back end, while others control user-facing AI experiences. This move ensures that doesn't happen. Hardware matters, but people matter more. One of the most underappreciated aspects of this deal is the engineers who moved with it. Designing inference-first hardware requires a very different mindset than scaling GPUs. It's about latency budgets, scheduling guarantees, and power efficiency under predictable loads. Groq's team had spent years living in that world. By bringing those engineers into Nvidia, the company imported not just IP, but intuition. That kind of knowledge transfer is hard to quantify and impossible to buy off the shelf. There's a historical parallel here. Nvidia's early success with GPUs wasn't just about silicon, it was about the people who understood parallel computing before it was fashionable. This feels similar. Nvidia is quietly assembling a second wave of expertise, this time around inference, before the rest of the industry fully realizes how hard that problem really is. For startups, this move raises the bar. Specialized inference chips were once a way to differentiate. Now, that advantage risks being absorbed into Nvidia's ecosystem. Cloud providers face a different tension. If Nvidia controls both training and inference pathways, clouds must decide whether to double down on internal silicon or deepen their dependence. Competitors feel the pressure most acutely. It's one thing to challenge Nvidia on training performance. It's quite another to challenge it across the entire AI stack. This deal narrows a space where rivals can operate independently. At the same time, it may accelerate innovation. Startups might pivot toward niche inference use cases, edge devices, ultra-low power systems, where general dominance is harder. Nvidia isn't killing competition, it's forcing it to specialize faster. Inference hardware is likely to fragment. There won't be one chip to rule them all. Instead, we'll see a spectrum: ultra-fast data center inference, energy-efficient edge inference, and domain-specific accelerators. Nvidia's goal isn't to own every chip, it's to own the platform they all plug into. Licensing inference technology gives Nvidia flexibility. It can adapt designs without locking itself into a single architecture. That's crucial in a field where workloads are still evolving rapidly. In the future, the most successful AI hardware won't be the most powerful. It will be the most predictable, scalable, and cost-effective. Nvidia is positioning itself to meet those criteria before they become industry standards. This deal didn't come with flashy keynotes or benchmark charts. That's what makes it dangerous. Nvidia moved quietly, early, and decisively into the layer of AI that users actually experience. By the time inference becomes the obvious battleground, Nvidia will already be entrenched. That's the hallmark of its best strategic moves. GPUs weren't inevitable. CUDA wasn't inevitable. Inference dominance won't be either. But Nvidia is doing everything it can to make it feel that way. If this strategy works, we'll look back on this deal not as a footnote, but as the moment Nvidia ensured it wouldn't just power AI, it would shape how AI shows up in the world. Thanks for watching. If you enjoy hearing about stories in tech and you want to support the channel, the best thing you can do is to like and subscribe. See you for the next one.